Okay, so in this video, we're going to go over solving systems of equations by substitution. Now, substitution is a really good method to use algebraically. Right? We went over graphing, which isn't all helpful if we're looking for fractions or when the solutions are fractions. Right? And a nice algebraic method, right, is a solving by substitution. Now, what we have here is a system of equations. And if I have a system where if we see here the coefficient of one of the variables is 1, I'm going to solve for that variable. Right? So the idea here is that you solve for one variable, one of the equations, and then you plug it into the other one. Right? So for instance, I'm going to take this equation here, x plus 3y equals to 5, and I'm going to solve it for x. 5 minus 3y. Okay, so now I have an equation here that's solved for x. So what I do here, and here's where the substitution comes in, I'm going to take this part here, and I'm going to go into the second equation, the one that I haven't worked with yet. And whenever I see the x, I'm going to replace that x with this quantity 5 minus 3y. Now, what this does is that now we have one equation in one variable, right? That variable being y, which I can solve rather easily, right? So what we'll notice here, I'll distribute here, right? 10 minus 6y, that plus 3y is here, equals to 4. Right now, this equation in one variable becomes much easier to solve, right? So be careful with your signs here. Negative 6y plus 3y is negative 3y equals to 4. Subtract 10 from both sides, and we get negative 3y equals to negative 6. Divide by negative 3, and we get y equals to 2. Now, I'm not done. Right, I have a system of equations, so the solution to the system is an ordered pair. I don't have an ordered pair, I just have the y coordinate. So I still need to solve for the x coordinate, but with the work that I did earlier in substituting, that should be pretty straightforward, right? If y is 2, I'll take the one where I substituted and plug in 2 for x. We get 5 minus 6, x equals to negative 1. And we get negative 1, 2 as my solution, right? My ordered pair. Remember that first ordered pair? Right? Always, that first coordinate is always the x value, so negative 1, 2. And you can always do a quick check, even a mental one, right? If you plug in the values into both of these equations, you should get a true statement again for both of them, right? Now I can do that off to the side here, right? If I do a little check, right? X is negative 1, so in equation 1, we got negative 1 plus y is 2 equals to 5. So here we get negative 1 plus 6 equals 5. Negative 1 plus 6 is 5 equals 5, and that is in fact a true statement, right? And then the next one, right, just to again make sure, remember, it's a solution because it satisfies both equations. 2 times 1 plus 3 times 2 equals to 4. So this is 2 times negative 1. So 2 times negative 1 gives me negative 2 plus 6 equals to 4, and we get 4 equals 4. So that checks out as well. All right, so we do in fact have a solution. Okay, so what happens when none of the coefficients is equal to 1? So let's try another example where that is the case. All right, so let's take a look at the system that looks like this. We have 3x minus 2y is equal to 18. 5x plus 10y is equal to negative 10. Excuse me. Ugh. Okay, now in this particular case, none of the variables has a coefficient of 1. I can really technically solve for any variable that I want in any equation, right? But what I notice here is in that second equation, all the coefficients have a common factor of 5. So what I'm trying to avoid in this is to avoid fractions as much as I can until the very end, right? If the answer is a fraction, well, there's no working my way around it. But in the intermediate, I can do things to not have to work with fractions all throughout the way. And the way I'm going to do that here is I'm going to take this one here, this equation, all right, and what I'll do is I'm going to solve for x, right? Now the reason for x, what we'll see in a second, is when I move the 10y to the other side, we get 5x is equal to negative 10 minus 10y. I'm going to divide now everything by 5. And what we notice is all of those values are divisible by 5. 5 divided by 5 is x. Negative 10 divided by 5 is negative 2. And also negative 2y here. Right? So now we have the x equals, right? With a coefficient of 1. Now that makes it easier going over here into my second equation, right? Or the one that I didn't work with, I should say. So 3. And here's the substitution. Instead of x, I write negative 2 minus 2y. Minus 2y equals to 18. All right. And now we go ahead and we distribute that 3. So we get negative 6 minus 6y minus 2y is equal to 18. Combine the like terms here. So we get negative 6 minus 8y equals to 18. Add 6 to both sides. And here we get negative 8y is equal to 24. Now we divide through by negative 8. And we get y is equal to negative 3. All right. And now the steps are similar to the problem we did before, right? We found our y. So now let's find our x. Negative 3. Excuse me. Get a little sloppy here. Negative 3. Now be careful with your signs here, right? Watch your arithmetic here. Negative 2. This becomes plus 6. So we get x is equal to 4. And we get the ordered pair 4, negative 3. All right. And I can leave it up to you to double check your answers here. But we do in fact one solution for this system of equations.